Thank you.
I looked at this page your dad sent me a little bit ago. It looks like you understand that. You did perfect on it.
Oh, cool. Awesome.
Okay.
Cool.
So, he suggested we work on some of the previous stuff we worked on.
Sure. Yeah.
But I have some ideas of my own.
Okay.
Now that we've decided or discovered that arithmetic is not your problem, let's go on to solving algebra equations.
Okay.
In other words, the paper you did tonight was figuring out how to solve two linear equations at one time. Okay?
Yeah.
So before you can do that, you need to be able to figure out how to solve one. So let's make sure you're really proficient at that.
Sure.
Okay, so I've got a book here, an algebra book, and it's got this page full of linear equations. Let's go through a few.
Sure. Okay, so
just read the next line to me. You don't even need to tell me what you're doing. Just what would the next line be?
So you'd add 3 to both sides.
Okay.
So it'd be 2x is equal to 4.
Okay, did the same thing. We're adding 3 to both.
2x is equal to 10. Okay, yeah, I just need to write it out.
That's a common mistake you're making.
Yeah.
Okay, so what's x equal to?
X is equal to 5.
Okay. Find another one.
Okay.
Now tell me, this is always tough to do. I'm assuming that you've had all of this.
Yeah, we've done that before.
Okay, so let's just practice it.
Okay.
This is the next thing this is the next step up from arithmetic, basically.
Okay, cool.
Figure out where it is that we're having a problem.
Okay.
So what's the next step here? Conceptually, what are we going to do?
Well, we could do it either way. We would subtract 3 from both sides.
3?
So from 3/8 from 9/8.
3a. Well, 3a.
Yeah.
Okay, not 3, but we're going to subtract that whole thing from both sides.
Okay, yeah.
Okay?
To get rid of that, yeah.
Okay, so what's the next line?
13 is equal to 12 minus 8.
No. Remember that we're...
9.
Okay, let's change the way we do things.
Okay.
Let's start doing this.
Okay.
Because that's what we have to do to get rid of the 3a.
Yeah, I just need to write it down. I have a piece of paper now.
That's okay. If you have a piece of paper and pencil, then start writing it like this.
Okay.
And you will quickly stop making that mistake that you keep making.
Yeah.
Okay, so what's the result when I do this? I get 13 over here.
So it'd be 13 is equal to 6a minus 8.
Now what's the next thing to do?
So you'd add 8 to both sides. Then 21 is equal to 6a. Then divide it by 6.
Now simplify 21/6. How do we simplify that?
3 goes into 21 7 times, and 3 goes into 6 2 times.
Okay, good.
Cool.
Now, hopefully, you're going to prove me just as wrong on this as you did on the arithmetic.
Okay.
You want to get to where you're perfect at these.
Yeah.
You don't want to be in doubt at all. If you're in doubt at any step, you're going to have problems. It's going to prevent you from having any confidence whatsoever in your ability to solve an equation. Okay? And you absolutely have to be able to solve these kind of equations.
Okay.
Okay? So what's the first step?
Subtract 2b from both sides. And then you would...
What's the next line?
11 is equal to 15 minus 8b. And then you would subtract 15.
Let's back up 1 second here.
Okay.
Would you rather have a negative coefficient in front of the b or a positive coefficient?
Probably a positive.
Okay, so let's go back 1 step here. There's absolutely nothing wrong with doing it this way. You're going to come up with the correct answer. But whenever negatives are unnecessarily introduced, it results in more mistakes. People make more mistakes. So if you have a choice on how to do this problem, let's move the 6b from the right to the left, because what's going to result when we do that?
So
we're going to add 6b to both sides.
Yeah. So you would get 8b plus 11 is equal to 15.
Now what?
Then you would subtract 11 from both sides. And then you would get 8b is equal to 4. And then, divide 8b, so it would be, so divide by 8, so 4 over 8, simplified, 1/2.
Good. Very good. Okay, let's do more of those. Little tricks like that help a little, I think. They're not huge. You would have gotten the same answer doing it the other way, but you would have had to deal with negative numbers. And notice, not only would you have had a negative 8b on the right, but then when you move the 15 over to the left, you would have had a negative 4 there.
Yeah.
So you would have had negatives on both sides. Instead of in this, the way we did it here, we have positives on both sides. So when you take that very first step of solving an algebra equation, you always have a choice as to which side you're going to put the variables, which side you're going to put the numbers on, or the constants. Well, make that choice such that the coefficient of b is positive. It may still result in a negative coefficient on the other side, but that's okay. It's easier to work with positive coefficients of your variables.
Okay. Cool.
Let's keep up a notch.
Okay. Okay, so first you want to do 2 times what's inside the parentheses.
Okay, so what's the next line?
So on the left side it'd be 2x plus 12 is equal to negative 2x plus 8.
Good.
And then you could add 2 to both sides.
2?
2x, my bad.
Okay.
Then you get 12 is equal to x plus 8.
Hold on. Make sure you don't do this incorrectly.
4x is equal to...
4x plus 12.
Plus 12, is equal to 8.
Okay.
And then you would subtract 12 from both sides. And then that'd be negative 4 is equal to 4x. 4x is equal to negative 4. And then x is equal to negative 1.
It's funny, when you're dividing, when you're doing that last step, I don't feel like you need to do this.
Yeah.
You do it automatically. But when you're subtracting or adding a number, it's like you need to do it. And that's fine. Let's do it this way for a while. You're going to get to a point where you're going to drop that. And you'll know and you won't make the mistakes. But,
okay, cool.
Yeah, let's keep drilling here. Let's get a little harder.
Cool.
Let's see.
Okay, so first on the left side, the next line would be negative 12x plus 4 is equal to negative 10x plus 4.
Plus what?
Oh, plus 40 minus 14x. Then on the right side, you can just combine the like terms, so negative 14x plus negative 10, so negative 24x plus 40. And then on the left side, it would be negative 12x plus 4. And then you can add 12x to both sides.
Think about that one more time. You have a choice of adding 12x to both sides or adding 24x to both sides. Which one's going to result in a positive coefficient on the x?
Probably on the right side.
Right, let's do that.
Okay, so
you want to stay just one step ahead. In other words, when you're thinking about how to do this.
Okay.
The little thing, but it's not a little thing in the end. Okay, so now what do we have?
Now we have 12x plus 4 is equal to 40.
Good.
And then subtract 4 from both sides. And then you get 12x is equal to 36. And then x is equal to 3.
You're going to be perfect at these in 10 minutes.
Cool.
You're already getting close.
Thanks.
Of course, I'm going to make them harder and harder.
Yeah. Okay.
Now, whenever you're solving an algebraic equation, no matter how complicated, everything we've done so far has just had an x and numbers, right? That's called a linear equation. Okay? Even if it's got fractions like this, it's still a linear equation. It's not x squared or anything.
Okay.
So, there's always multiple ways to do them. And kind of the secret is finding the best way. And like when you have a choice of which side to move x to, try to move it to the side that's going to result in a positive coefficient.
Okay.
This problem here, what's an obvious first step?
You just have to multiply 3/4 times what's inside the parentheses.
Distributing the 3/4. In other words, we multiply 3/4 times 4/5 x, and then we multiply 3/4 times minus 2. Okay, and then we go through the same procedures we did with everything else. But in this particular problem, there's actually something that works much better than doing that.
Okay.
Notice that the denominator of both sides of the equation is 4. So I'm going to multiply both sides of the equation by 4.
Okay.
See what's going to happen? We just eliminated the denominators. So what's now left on the left side? Do it in pieces. In other words, just do that and that. So what's left after you do that?
3.
3 times 4.
So 3 times 4/5 minus 2.
Minus 2 equals
11.
Okay. Now, at this point, we want to distribute. We cannot add 2 to both sides because this minus 2 is really a minus 6 once we distribute. So let's begin by multiplying that.
Okay. So yeah, 12 minus 2.
Okay. Now what next?
Would it be like, so like for the equation, 3 times negative 2, would that be negative 6?
Excuse me. I'm so sorry.
No, you're
That's
good.
the last thing you need is your tutor making mistakes like that.
No, you're good.
All right. Now what?
Okay,
Good
so
catch.
now you
Good
would...
catch. That was on purpose on my part.
Thank you. So you just add 6 to both sides
Okay.
first.
So what do I have next?
12 over 5x is equal to 17.
Okay. Now what?
And then you just divide it. So you could just...
Hold on.
It's same switch flip.
What's now?
Same switch flip. So you do 12 over 5 times 1 over 17.
Okay, I don't particularly like that way of doing it. Let me help you here. We
Okay.
got multiplication and division going on over here.
Okay.
So I could do it in 2 steps by multiplying both by 5 and then dividing both by 12.
Mm-hmm.
But I'm going to do that in 1 step, and that's what you were attempting to do.
Yeah.
But the same switch means that instead of doing 2 steps, I'm going to multiply both sides by the reciprocal.
Okay.
That's what I think you meant when you said what you said. In other words, if I multiply the left side by the reciprocal of this fraction, it'll get rid of it totally. The 12s will cancel, the 5s will cancel, and I'll end up with x.
Okay.
So now I have to do that to the other side.
Okay.
That's the way I like to do it. It's 1 step instead of 2.
Yeah, it's
And
quite easier, actually.
It's not as complicated as dividing by the coefficients. You could also do this, but that will throw a lot of people for a loop just because they don't like dividing by fractions. But of course, notice when you divide by a fraction, it's the same as multiplying by its reciprocal, which is what we did.
Okay.
Okay? So you can think of it however you want. But the way I think of it is just multiply both sides by whatever the reciprocal of that fraction is.
Okay.
Okay? And then we have x equals 105 divided by 12. No. Wow. 80.
There we go.
By 12. Is 85 divisible by
No.
anything that 12 is divisible by?
No.
No.
No. Yeah.
No, it is not.
No.
So that's your final answer. Okay.
Cool. Awesome.
Now, let's talk about systems of equations.
Okay.
A system of an equation would be where I have an x and a y equals 10. And I tell you y equals 2. Hold on a second. Let me back up. If I give you just this equation, you can't solve it because there's an infinite number of solutions.
Yeah, and there are two variables.
There's 2 variables and only 1 equation. So that can't be solved. But if I give you a second equation, now I have 2 equations and 2 variables.
Yeah. Would you do x plus 2 equals 10?
Yeah. And then subtract 2 from both sides, you get x equal 8.
Yeah.
Okay? So,
cool. Okay.
the other thing about system of equations is if I say x plus y equals 10 and also x plus y equals 8, that can't be true.
No.
If I give you those 2 equations with those 2 variables, then there's no solution. There are no values for x and y where both of these would be true.
Okay.
If I give you a second equation that is merely a multiple of the first, there are 2 equations and 2 unknowns, but I still can't solve it because I haven't added any information. In other words, the second equation is exactly the same as the first. If it's a multiple, then I can't progress any. So it's not just any 2 equations that will produce a unique solution. They have to be 2 independent equations. And if I gave you this equation, Now, the second one is not a multiple of the first. It's completely different, and there is a unique solution here. And because we have them in this format, you're always allowed to add or subtract equations. In other words, if I have a plus b equals c and I have x plus y equals z, then I can always add these so that a plus b plus x plus y equals c plus z.
Okay.
No matter what the equations are. I mean, they can be completely out from outer space relative to one another. I can always add equations. I can also always subtract equations. In other words, a plus b minus the quantity x plus y is always going to be c minus z.
Okay.
So all I did was subtract the bottom equation from the top equation.
Okay.
They're about to teach you is how to solve two equations and two unknowns. And there's two techniques. One is called substitution, the other is called elimination. This is elimination, and it's called elimination because I'm going to get rid of one of the variables.
Okay.
If I add these two equations together, what do I get?
X plus y.
Well, no, add them like this. Add them vertically.
Oh, so 2x.
Okay.
So 2x.
What's that?
Would that just, like, cancel out?
Yes. That's the whole point of its name, elimination, is one of the variables gets eliminated.
Okay, so, yeah, it's be 2x is equal to 15, yeah.
Which means x is equal to 15 halves. Well, now that I have x, I can go back in and solve for y.
Okay.
If I substitute 15 halves right there for x, notice that I can come up with the solution for y now.
Oh, cool.
Okay? Really easily. Now, I made these numbers up out of my head. I didn't intend to make fractions. But that's the way elimination works. Now, the other technique that I mentioned was substitution. Those are the two you're going to have to memorize. And substitution would be this one. If my second equation is clearly defined in terms of one of the variables like that, then I don't need to eliminate a variable. I'm doing a substitute.
Okay.
So I'm going to go back and I'm going to say x plus 2 equals 10, so x equals 8. Once I've solved for x, well, I already knew what y was. Y was equal to 2. But maybe I have this. Maybe I have x plus y equal 10, and then y equal 3, make it 4x. There's my second equation.
Okay.
Okay. So now you would have what? How would you solve these two systems of equations?
Would you combine 4x with x to make it 5x plus y equals 10?
You'd want to use substitute. Yes, that's what you would do. You called it combining. This is what they're going to call substitution. In other words, solving a system of two equations by substitution is what we're doing. We're going to substitute in place of y, we're going to substitute 4x. So we would have x plus 4x equals 10. That's 5x. X equal 2. Once you've solved for x, now y is 4 times 2. So y would equal 8. Okay? So that was the technique called substitution. The other technique was called elimination. And you use elimination whenever you're in standard format. Standard format is this. That's the standard format of a linear equation, or format of a straight line. Now the other format we've been working a lot with is y equal mx plus b. That's slope-intercept. That's the slope. That's the y-intercept. And the other format we've worked with is point-slope.
Okay.
So those are your three formats. That's standard format, slope-intercept format, point-slope format. And you should be well familiar with all three of them. But when your two equations are in standard format, elimination is almost always the best thing to use to solve it.
Okay.
Okay? I mean, just because it is. In other words, if I have 2x minus y equal 10, and I have 4x plus 2y equals 6, can I eliminate a variable by adding or subtracting these equations?
No.
No, it won't disappear. But I'm allowed to do anything I want to either equation as long as I do it to both sides. So what could I do to the top equation? To multiply it by 2.
Yeah.
That's going to make it 4x minus 2y equals 20 instead of that.
Cool.
Now, notice what I can do.
Now you can cancel out both of them.
Well, I can add them.
Or add them,
and in the process of adding them, the y is going to disappear. So I got 4x plus 4x. Over here I got 20 plus 6. I've solved it. X equals 26/8 or 13/4.
Okay.
Okay? So those two techniques you're going to be dealing with for a long time. I mean, I don't know how far you've gotten into either one. From the paper that I'm looking at that your dad sent me, it looks like you're just kind of getting started on it. But that's where you're headed for quite a while, is solving two equations and two unknowns. And this is the way to graphically do it. If you graph each equation, where they intersect is the solution. That coordinate, the x-coordinate and the y-coordinate, is the solution for these two equations. You got that equation and you got that equation.
Yeah.
So, all right. I will let you go. Boy, you put in the hours the last couple of days.
Yeah.
But I see progress.
I do too.
Okay.
Thank you. Yeah, thanks.
Talk to you later.
All right, sounds good. All right, bye.